Well, I guess we can get started. So let me introduce our speaker for today, Helen. She comes from China, and then she works right now in Japan. She's a development engineer at Entity Communications, and she's going to present on how to visualize OT ICS networks for security measures. So Helen, take it away.
Thank you very much for introducing me. So I'm Wang Jia, and you can also call me Helen. That's my English name. And I'm a development engineer at NTT Communications. And thank you very much for joining today's webinar. It's really a great honor for me to give a presentation on how to virtualize OT SAS networks for security measures. Before I start my presentation, I want to talk something about the OT-SAS. Well, OT stands for Operational Technology, and SAS is for Industrial Control Systems. These specialized computing systems are usually used for manage, monitor, and control physical devices, infrastructures in industries such as manufacturing, energy, and transportation. Ensuring the normal and safe operation of OT-SAS is very important because the interruption of a system may cause halting production line, then leading to delays in product delivery and then substantial financial losses. So today's talk is about how we utilize the Zeek to realize the virtualization of OT-SAS networks. This is the agenda of today's talk. So let me talk about the background in Japan first. Nowadays, we are seeing more and more attacks targeting small and medium-sized Japanese manufacturing companies because their security is not as safe as the that of large companies. Well, large companies, they have implemented intrusion detection systems or EDR systems, but smaller business, they lack proper OT security measures. The chart below is based on statistic data from the Information Technology Promotion Agency in Japan. And as you can see, SMEs, they tend to experience higher rates of malware, somewhere, business email scams, phishing, and targeted attacks compared to larger companies. One key reason is that the SMEs, they often don't have the budget to invest in comprehensive cybersecurity measures, making it harder for them to detect cyber attacks. Besides, the targeted attacks and attacks on control systems can sometimes act as the entry points for hackers to breach other companies. Here, I'd like to share a case involving a manufacturing company called K. Its subsidiary developed remote control equipment for communications with its suppliers, which had some vulnerabilities. Then these weaknesses were exploited, allowing an intrusion into company K's network through its subsidiaries network. This led to attacks including data encryption and severe damage on several servers and computers. As a result, automobile production across 28 lines at 14 plants of major community was completely halted due to a system shutdown for investigation. This caused a severe disruption across the entire supply chain, and it was confirmed that numerous suspicious emails were sent out, impersonating employees of Communicase Group. Well, this case highlights a crucial issue that the victims of cyber attacks can sometimes become the perpetrators themselves. When it comes to OT IDS solutions, there are plenty of options available in the market, both paid and free. Well, the chart below shows the top 5 OT IDS for 2024. These leading tools offer advanced features and strong support for OT environments. but they often come with high price tag. While the cost reflects their powerful capabilities and specialized supports, but it's also important to make a balance between these features and the budget constraints of the manufacturing floor, especially for SMEs. We need to ensure that the solution can fit their specific need without overwhelming them financially or operationally. So in today's market, famous OT IDS solutions are typically expensive and may not support all OT protocols. On the other hand, free OT IDS solutions don't support unique Japanese protocols, like CC-Link. So this creates a gap for an OT IDS solution that is not only reasonably priced, but also can support Japanese protocols. There is a clear need for a solution that can offer both cost effectiveness and the capability to handle the unique demands of Japanese manufacturing environments. Next, I'd like to talk about our motivation. Implementing security measures for production lines in SMEs comes with several difficulties. The first difficulty is that their top priority is maintaining the stability of the control system. However, outdated operating systems software, along with the concerns about the impact on existing devices after implementation, makes this quite challenging. Additional difficulties include a lack of system awareness, dedicated security personnel, and a strong focus on minimizing the costs. All of this make it even harder for SMEs to implement effective security measures. The same consideration applies to building security as well. Given the challenges and the fact that commercially available OT IDS solutions aren't a great fit for SMEs, we decided to make a different approach. We developed our own solution using the open source tool Zeek. By mirroring the communication data between OT devices, we were able to virtualize and manage OT ICS without impacting OT system itself. Next is about how do we use Zeek. Our device equipment with Zeek is very easy to set up. Just simply connect it to a mirror port of an existing switch in the factory. It's ready to go. There's no need to install any software on existing equipment because the device only mirrors the network traffic from the switch. And because it is not integrated into the system, it has no impact on operations. We process the logs generated by Zeek to make them virtualizable. This allows system administrators to monitor the system more effectively and enabling early detection of risks and preventing cybersecurity threats, vulnerabilities, and potential factory shutdowns, all without disrupting the operations. When we started using Zeek, we met several challenges. So here I'd like to share our challenges and the solutions to it. The first challenge is insufficiency. Well, by default, Zeek only support a few OT protocols, which led to the log output being insufficient for our needs. We also explored third-party Zeek plugins, but unfortunately, there wasn't enough information in the logs they generated. Here is a case study on the challenge we faced. The ICS NPP bucknet is a Zeek plugin for parsing and logging fields within bucknet protocol. Well, by default, the plugin can generate up to 4 files depending on the application protocol data unit types in the packets. However, to better meet our needs, we need to modify their Zeek code to consolidate all the logs into one single file, because the separate log files contains both relevant and irrelevant information. For example, consider the field name called object type. In some logs, it is included, but in others, it isn't. The inconsistency made it challenging for us to get a complete picture of the logs. So we decided to modify the third party's code to ensure it can output all the information that can be useful for us. Well, when there is a third-party parser available, we can modify Zeek's code to meet our requirement. However, some OT protocols are quite unique to Japan. For example, the Mitsubishi Electric PLCs made by Mitsubishi Electric Corporation are widely used in industrial automation for controlling machineries and processes. They hold a 58% share of the domestic market and 18% of the global market. These PLCs use CC-Link protocols, but there isn't a parser available for CC-Link. So we need to make a parser to virtualize CC-Link protocols. But the Zeek's parser are typically written in C++, and our team, we don't have expertise in C++. Creating a parser from scratch in C++ would have been quite complex. So we decided to adopt SPACY to simplify the process and make the implementation more straightforward. For your reference, a list of CC-Link family protocols is shown on the right side. Well, to tackle the first challenge, we used the SPACY. It integrates seamlessly with Zeek and allow us to extend Zeek's capabilities with custom protocol analysis. With Zeek, we were able to create parsers to efficiently analyze CC-Link family protocols. However, our initial experience with SPACY wasn't smooth because we are new to it. By closely following the operational document and actively engaging with the Zeek community on Slack for support and advice, we were able to overcome these initial challenges and get it working the way we needed. On the right side, you can see an example of the SPACY code we developed and along with the generated log. Next is about our second challenge. The second challenge we faced was lack of specification. Well, for OT protocols like TCP, HTTPS, DNS, it's relatively easy to find detailed specifications for their frames, explaining all the parameters in the packets. However, with OT protocols, it's a different story. We were able to locate the specification for Modbus without much trouble, but for protocols like CC-Link, things become more complicated. Well, CC-Link specifications are not open source, and we cannot simply find them through a Google search. To access the specifications, we had to join the CC-Link Partner Association, which required us to pay annual fees. But this step was necessary to ensure that we had the correct information for our work. After a parser has been developed, we faced another challenge, the absence of pickup files to verify its accuracy. Well, we can easily obtain a wide range of pickup files for testing at Dynamite Lab. But OT-related ones are typically internal to the plant, and not publicly accessible. Although we could create our own pickup files for testing, relying solely on self-created data to validate the parser isn't ideal. The real-world packets data contains complexities and unexpected scenarios that we can't perfectly replicate. So if we only stick to our own test data, we might miss some important details. And that could affect how well the parser works when it is actually used in the real-world situations. To obtain the pickup files, we tried several approaches. Firstly, we used the test tools provided by the CC-Link Association. By adjusting the meters on these tools, we generate pickup files for CC-Link IE Field Basic protocol. However, these tools only cover certain protocols and not all of them. As a second solution, we took advantages of our connection with Company C. Well, through a POC verification process, we were able to acquire pickup files for CC-Link IE field and IE control protocols. Company C is well known for its advanced simulation technology and exceptional technical expertise. They have a strong track record in OT systems, with a team that has deep industry knowledge and extensive experience. Then in our collaboration, we set up a simulated plant where an automatic robot arm grabs and places products on a conveyor. It allowed us to obtain pickup files that are important for analyzing network behaviors and ensuring the reliability of our parser in real-world situations. This partnership with Company C provides us necessary data and valuable insights for validating our methodology and improving the accuracy of the parser. As a third solution, we created our own OT simulation system within our organization. This simulated plant contains two main parts, the controller part and the drive part. On the left side, we have a Mitsubishi Electric PLC unit functioning as the controller part. This unit manages and monitors industrial processes by processing inputting data, executing control logic, and handling outputs. Next to it is the drive part. It carries out the physical actions based on the commands from the PLC. As you can see, the controller part is made up of 7 components. The base component provides the physical support and electronical connections for the entire PLC system, ensuring that all the other parts are securely mounted and properly connected. Then the master CPU unit acts as the central brain of the system. It runs the control programs, manages data, and communicates with the slave CPU unit and the HMI. The slave CPU unit helps the master CPU unit by taking on additional control tasks and processing data. While the HMI is the user interface for the system, allowing the operators to see the system's status, input comments, and monitor the processes. Then the industrial switching hub connects all the networked components, making sure data flows smoothly and communications within the PLC system is seamless. Well, on the drive side, which operates based on the commands from the PLC, we have 2 rotary positioning tables, reflective sensors, and LEDs. The PLC directs the rotary tables to move and position itself accurately. Reflective sensors help to detect the position of the workpieces by sending and receiving light signals. And the LEDs are used to display the operational status of the system, such as running or stopped. This setup allows us to freely adjust the communication details and capture pickup files, giving us the flexibility to test throughoutly. Next, I will show how we utilize the virtualization of the log data. When we were developing our parser, we need to figure out which parameters matched the function in the target protocol. To do this, we referred to both protocol specifications and the pickup files. For IP protocols, while taking the CC-Link TSN SRMP protocol as an example, we started by virtualizing key details such as the source and destination IP addresses, the name of the OT protocol, and its function to a web UI. We then added features to calculate and display the date and the time of the first and last communications. As for non-IP protocols, we virtualized the source and the destination MAC addresses, OT protocol function, and the first and last thing as well. By virtualizing these details and tracking communication timestamps, we ensure that our parser could properly interpret and display the data in a way that made sense. The virtualization helps to monitor the communication patterns over time and analyze network activities more effectively. Besides OT protocols, we also realized the virtualization of information from other logs generated by Zeek. Well, we virtualized the IP addresses, MAC addresses, and the service a host is connecting to and connected from, the first and the last communication time from the connection log. And additionally, we were able to virtualize the host name, host or model type, and the operating system name from the 4 logs below. The information then was integrated into a web UI, offering a comprehensive overview of all hosts within the network. By comparing this data with the management ledger, user can spot any unexpected connections. And this not only help in identifying unauthorized or potentially risky hosts, but also enhancing overall network management and security. By ensuring all the hosts legitimate and continuously monitored, a secure and well-regulated network can be maintained, reducing the risk of security breaches and operational disruptions. Here, I'd like to share some practical examples of our device about how our device equipped with Zeek is utilized in the real world. The solution our team provides is designed to prevent security incidents before they occur. And it helps to address and mitigate the impact of significant damage to the manufacturing floor. Especially, it enables the detection of unauthorized hosts that may pose infection risks, provides notifications about the hosts running vulnerable legacy operating systems, and uncovers unexpected communications that could indicate potential security issues. With these capabilities, it ensures the integrity of the network and maintains smooth and secure manufacturing processes. At last, I will make a conclusion and talk about our future plan. From the initial engagement with Zeek and SPACY to analyzing and addressing each challenge we encountered, and finally to virtualizing the generated logs, our team has developed a streamlined process. When a new requirement comes from a factory or company, we first gather the protocol specifications and pickup files, then develop a parser using Zeek and SPACY, and virtualize the logs on the user's web interface. The process not only facilitates the quick implementation of OT protocols, but also ensures that we can swiftly adapt to emerging operational needs. Technically, our approach utilizes this extensive network monitoring capabilities and SPACY's high performance in packet data analysis, allowing us to perform deep packet inspection. In addition, the virtualization function translates complex log data into actionable insights, making it easier to monitor and secure OT environments effectively. Next is about our future plan. Since we are considering the small and medium-sized manufacturing companies in Japan, we plan to implement more OT protocols. The next two parsers we are going to develop are for Omlon Fence and SLMP. The Omlon is a Japanese electronic equipment manufacturer that leads in the fields of automation, and the Fence command is used for communications between devices in industrial automation systems. By increasing our support for OT protocols, we are committed to helping these companies to enhance their productivity, strengthen the stability of their industrial processes, and improve their operational security. That's all for today's presentation. Thank you very much for listening. If you have any questions, can ask me.
Thank you so much, Helen. And yes, we do have questions, and we have a question from Christian. So I'll let him speak if he can. Christian, can you talk?
Let's see if this works. I'm speaking right now, and I think, yep, okay, cool. Helen, thank you so much for this talk. This is fantastic work. I first wanted to compliment you guys for going through all this effort of establishing the traffic, of publishing your packages, of making all of this open source, including test cases and PCAPs. I think this is all as good as it gets. I'm wondering if you could speak a little bit to so whether you knew ahead of time what you were looking for in this traffic. So you basically sketched how you were working on initial versions of the parsers, how you then found that they were not necessarily providing you everything that you had hoped for. Did you know ahead of time what you were looking for, or was that sort of an iterative process?
Well, actually, we aim to, like, for example, the IP protocols, we aim to virtualize all the information so we can monitor all the traffics through a web UI. Before we start, we don't know for the function part, we don't know what to virtualize, and we are not sure whether we can get all the necessary information from the packet. So
yeah.
Actually, when we set some parameters using the CC-Link tester tools, that's just a test to pickups from the packets is just from tester tools, not the real world scenario. by just depending on that packets, we doubted the accuracy of our parser. So we utilized our cooperation with a real company that can provide a simulated plant that we can look deeply into the packets to see the real data. And then we used the specifications to compare with the packet data to say whether all the information is included.
Yeah,
But
got it.
yeah.
Yeah,
But
yeah, thank you so much.
Actually, I want to say a little bit more because the cooperation with another company will cost us some money. So as a third solution, we choose to build a simulated system within our organization, so we can make a decision on the design and to make it generated the package we want. And the whole system is just like the real factory environment. So this after we created this system, everything become more easier for us.
This setup right there blows my mind. I think this is fantastic, because this problem of like not having PCAPs available is very common in parser development.
Yeah.
But usually people are sort of wondering about like, oh, I wonder what's the server software or what's the client. You basically have the whole thing sort of right in front of you in physical form. This is amazing. So congratulations. I think this is super cool work. Thank you.
Thank you very much. Actually, we struggled a lot for getting the pickup files, but step by step, we overcome it.
Yeah, congrats. I was curious, are you planning to maintain those packages for some amount of time? Or I don't know, like sometimes it's hard to commit to that in the long run, but like if you're planning to, that would be wonderful. Let me put it that way.
Yeah. And we keep these pickup files for testing in the future.
Yes, I noticed they're in there. That is fantastic. Thank you. Cool.
Thank you very much.
I think that's all I had, Fatima. Wonderful. This was great. Thank you again.
Awesome. Thanks, Christian. And are there any other questions from other attendees of this webinar? Okay, I do not see any further questions. So let's thank again our speaker for today, Helen. And congratulations for this amazing work. And we really enjoyed the webinar. So thank you so much for taking out some time and giving this wonderful presentation. So thank you so much, Helen. That was
Thank you very
great. So
Thank you all.
before we depart, I just wanted to remind that next week we are going to have another webinar at 10 a.m. Pacific time. And our next speaker would be Aaron Scantlin from NERSC, and he will be presenting on how Zeek helps secure open science. So hopefully I'll see you guys all in next webinar. And thank you so much for joining this webinar. Take care, everyone. Thanks. And thank you so much. Take care.
Okay, take care.